Alright, let's see how much I can get done today. Oh god. So, we're about done. We're about done setting things up for the visualization. Yeah. So let's see, year 2022, day 1. That's this. Okay, not a lot to this. Now let's see, what's the actual problem? And how can it be visualized? Okay. Now, so it's the amount of calories in a food item, and new lines represent different elves. I see. Yeah. Okay, so it's an array of arrays, so we need all of that. We need to return all of that. So let's take an arena for allocation purposes. Well, I mean, ref arena, and that is our number. Adding to the sum, this sum, max sum. Yeah, and what's the A1? Find the elf carrying the most calories. How many calories in total is that elf carrying? Okay. So there's the amount of calories in an item, then there's multiple items per elf, and there's multiple elves. Okay, well, I mean, step 1 would be to actually get all of the numbers into some kind of an array that we can just use easily. Carrying the most calories, yeah. 24, yes, that one. Okay, well, this number right here is the individual number. This sum is the sum per sort of per elf, and the max sum is just something we're keeping track of them. Okay. So what data do we want out of this? Day 1 result. We want something like, I mean, whatever, we can make them ints. I mean, it's an array of arrays. Wow, it's like that, but I mean, while we're iterating over this stuff, we might as well just store the sum. I mean, we can just even do this, right? Where each elf is just a bunch of ints, which is how many calories they carry. Calories, int, calories, well, just sum, and like right here we can store max sum. Yeah, so it's an array of these structs. That's what we actually want out of it. Yeah. Well, yeah, we don't know ahead of time how many elves there are, so nobody else is going to be using this arena presumably, so because it's kind of a single-threaded allocator. So we could just keep allocating. Although I do kind of want the calories to go all into one array, otherwise it's gonna be a little dicey. All the calories, all the sums. I mean, unless you want to iterate over the whole thing twice. To know how much to store and then to fill in the rest of the stuff. Although, yeah, I mean, doing all of this all at the same time is kind of, I mean, you almost kind of have to though. Because yeah, you can parse out all the numbers, but it's not like you're gonna be able to, I mean, well, you can parse out all the numbers, store them, and also store the lengths elsewhere. And then copy it over to the copy it over. Huh. Yeah, I mean, I guess we can do that. Right? Let's see, let's just try that. Like circle. Let's see. All right. I mean, that's gonna. Yeah, not the great. I mean, this would be convenient to use. I mean, I suppose. Well, I mean, even if you don't store the sum, you still need to store something. Like you need to store how many entries there are in it. I guess I can just call that scratch. Yeah, so if we don't want to reallocate just constantly, then all the calories can go next to each other, all the sums can go next to each other. Well, I mean, this is a slice, so this is ultimately a pointer, and this is ultimately a pointer as well. Unless, I mean, you could also represent it like this. and not even store the sum, and then like you could also do that. Then you wouldn't be able to like look up a specific elf necessarily, but you don't necessarily need that, really. Hello, digs? Alright. I mean, we could store that. I mean, it's still 2 arrays, right? There's no way around that. Max sum, sums, I mean, sums would just be that. And max sum would be that. Three arrays. I guess I'll change this to ints. Alright. Well, the first array can be built out just as we're going through this. Of course, the second and the third cannot. We kind of want to build them all up, all simultaneously. And not knowing how big they are. It means we need to pre-allocate. Well, we have the scratch space. Might as well pre-allocate them there. Actually, can we do this? Well, I mean, it's not even that, it would be something like that. Long size. I mean, we have 3 arrays, so like... this would be item counts and sums. I wonder if that will just work. Does that work? No. No, first of all we need to pass those things in. Arena, circular buffer. I mean, maybe I should just rename it to Scratch. Yes. Yeah. Cast int array. Well, unresolved externals. Man, the compiler not inserting these things into the executable is just so good. In functions through starts. So array equality is now not inserted into the executable. Why? And why is it not inserted in a different function? So this is fine, but this isn't. And it's not even the function that I'm modifying. Start. I don't think I'm using it. Run tests. Internal array equality. The compiler bugs all over the place. What a waste of time. What a waste of time. Is this array equality T8 equals status. Okay, that's a mangled name clearly. Internal array equality. Can I even find it? Array. I don't think I can find it all that easily. I mean, we have all these mem sets. These are at least. Version dsymd. That's good to know. What is this array equality nonsense? Do I have to rewrite this like? I mean, it's the cast, right? Like if I do void, then it compiles. Okay. As soon as you cast, like it's specifically this part that's failing. Yeah. Do I have to have my own version of that thing? I guess I do. And they say this compiler is not in beta. Wow. Alright, might as well figure out how to write a template, I guess. Well, I mean, I kind of already have one. It's max and min, right? So like this stuff, you just have two parameter lists. Rcast. So it returns how do you, like, it's rcast. How do you use these templates again? Templates, yeah. Exclamation mark. It's like that. But I wanna call something. Oh wait. something like that. So it has one, I mean, two from, I guess it has two parameters really. And this is like from, and it returns two. And let's just write it as a cast for now. Cast to v1, like it's something like this. Do you need like two parameter lists or? Yeah, so that actually seems to be working. Interesting. Okay. To result equals pointer 0 new 0 length. What's the pointer? Well, what's the length? This is like u long or something. Length is v1 length divided by the ratio of v1 size of divided by 2. Well, actually that would be 1 size of. It's from size of divided by 2 size of. Actually that doesn't make sense, because if this is 1 and this is 4, then we want to divide by 4. And if this is 8 and this is 4, well, it's just times from size of them. Yeah, I mean, this just gives you the length in bytes, because this is the length in elements. So you multiply, that gives you the length in bytes, then you divide, that gives you the length in elements. So the result is v1 well, it's actually cast to star. So we want to take this pointer, cast it to the pointer to the whatever we're converting to, and then slice it from 0 to this new length. So something like that. Can I do this? Will that work? That seems to work. Okay. Empty declaration. Okay, I have no idea if that's actually working though, so let's find out. Okay. So this calorie scratch underscore thing has a length of that much. Presume that's that many bytes. So if we divide by 4, that's the new length we expect. F11. Length is that, so that seems fine. Okay, so calorie scratch has that length and the same pointer. Yes. Decompiler is bad and does not insert whatever internal function it needs into the executable to make this work automatically. So I have to implement the cast manually. Okay. Can I do it like right away? Of course, this allocation, like, we're gonna be allocating arrays all over the place. So it would be nice to be able to just do that. Let's see if we can just make that happen. So like, what is this? T array alloc. Actually, is this even allowed? Result is alloc rcast okay, well, it compiles. So it's like a template, right? It's like, is that... Wait. Okay, so that is a... Oh yeah, it has no waiting for the type, really. Except from the return. It's like here, I want an int array. What if I comment this out? None of the overloads are callable with arguments. Nothing ulong. Huh, interesting. I mean, it's calling itself here, so... int is this something? Oh, yeah, that just works. Such power is possible, I see. Yeah, but what did it produce? Well, actually, to make it more debuggable, let's see. Void star buffer is that, and then we rcast the buffer. F11. Okay, well, the buffer has that length, and the result has this length, which is that divided by 4. Same pointer though. And what's alignment? 4. Okay, well, I mean, this is working fine. Okay, well, let's use it. Maybe this can just go inside the arena. Or even inside, like this, like for now. Maybe I'll pull it out. Later. Okay, so we want that, and we want that. And this is just some large amount of I mean, it's really an alloc array kind of code. That's fine. Does this actually work? No. Because we are allocating with too much. Too much. I'm guessing it's the last allocation. Yeah. Well, I mean, free size should be that, and so we step in there. What do we got? Buffer used that much, length that much. Okay, so what's this? Minus that. Oh god. Minus that. This. And size is more than that? What's the alignment? How? Wait, why did we? That's interesting. So let's stop there. Step in, step in, step in, step in. Oh god. Okay, so get a line offset. Offset is 2. Huh. How did that happen? I mean, if we allocate a bunch of integers, all of which have alignment of 4, then how can we possibly be misaligned from that? Yeah, this does not. I mean, this is alignment used. happens with the first alignment. Offset is 0. Okay, so we are aligned. Use the 0 pointer as that. Used is new used, which is that much. No, because... Wait. Oh, it allocates the size. Oh, I see. It allocates that size, but that size could be not a whole multiple of the number of elements that we are allocating. So it should probably round it, right? Oh. I mean, this is size in bytes. Which is what we want right now. Just this is how many we want in bytes. I mean, we could just divide and multiply to get like a rounded size. Oh well. Whole size or something is size and alignment minus 1. Just knock out the bits there and then allocate now, so we requested that much, but we're actually gonna allocate less than that, except this is not... How did that happen? I mean, all I wanted to do is mask off. Oh, wait. All I did is I capped the lower bits and masked them off. It's actually that. Yeah, whole size is 2 bytes less than that. Yeah. That seems to be working. So now this should work, and just as is. Whole size is that much, yeah. Yeah, allocated. Okay, so now Scratch, if we look at Scratch, used is the same as size, so we use the whole thing, as expected. Okay, what time is it? 2023. Oh god. Yeah. That's really all I have time for today. I guess, do we have any to-dos? Well, that's what we're doing right now. Okay, let's just leave it to do for what I was planning to do with this. Fill the arrays with appropriate data and copy the results to the arena. Yeah, that's the plan. These arrays should probably be dynamic as we need to keep track of how many dynamic like elements we filled. I mean, they're not really dynamic because they're going to be reallocating, but they are dynamic, kind of. But really, their dynamic nature will just be like it'll just be an array and a count of how many things have been pushed onto it. Yeah, well, that's fine. Start on 2022, day 1 visualization. Alright, that's all I have time for today. See you later.